Hello, everybody. Welcome to another virtual workshop series for our well-architected framework. As you know, technologies evolve, and certainly finding the most efficient use for our computing resources and still meeting our system requirements is important. So we're going to talk today about how monitoring, specifically with CloudWatch, but also with some other tooling, is really important for monitoring and enabling performance efficiency. Our workshop today will be a 100 level guide. So we're going to work through some CloudWatch dashboard views. We're going to look at health and how you can monitor your workloads. And by the end of this workshop, we really hope that you can have an understanding of how to use CloudWatch for metrics and alarming, and how to also enable end-to-end tracing for some workloads as well. So my name is Eric Pullen. I am the performance efficiency lead for the Well-Architected team. And so today we're going to talk about how monitoring plays a critical role in performance efficiency. So as you've seen in other parts of this series, we have 5 pillars of our well-architected framework. And I'm going to focus today on performance efficiency. That is also the pillar that I lead. But what does performance efficiency really mean? And it's all about the efficient use of resources to maintain efficiency as demand changes. So we want to make sure that as business and technical requirements are changed, that we have technologies that will evolve to meet those needed changes. So when we're developing or building or operating workloads, we need to make sure that we have decisions that are made to keep the flexibility for efficiency and that we can adapt to those changes in demand. And to take advantage of those new technologies when they become available. So we know cloud, one of the greatest features of cloud is that it's constantly evolving, and that we know that there's always new features to be added. And when those new features are added, you want to be able to quickly consume those if they're advantageous to your workload and bring it into your environment as quickly as possible. So, and why is this really important? Always having the best resources available for your workload is critical. It will reduce your operational workload. It will make sure that your systems are not only running efficiently, but also maybe even more efficient than they have in the past as you onboard new technologies. But most importantly, it frees you to focus on your business needs. Take away some of the technical aspects of your environment and really focus on the heavy lifting that you need to do for your business and meeting those workload requirements. Let us take on all of the resource requirements as needed. So it will increase the velocity to innovation, and it also lead to greater business success for your company. So I also like to start by looking at some anti-patterns. What are some things that we should avoid especially when we're talking about performance efficiency? One of the biggest things that I see a lot of customers do is they don't factor in all of the operational cost of making changes. So for instance, if you're spending months of effort to save 1 cent an hour on a particular EC2 instance, that's probably not a great use of your resources. You also don't want to continually impact your workloads by pushing back roadmaps for minor performance efficiency gains. So you always have to have that trade-off of is the thing that I'm going after really important, and will it bring the most value for my organization? And you want your team spending time building things that will help your customer. That's obviously the most important thing for any business, but certainly when you're looking at it as a technologist, we need to focus on the business perspective of things, not just focus on what the coolest technology is or that we have the latest and greatest of everything. We need to make sure that it makes sense for the business as a whole. And so we need to make sure that we understand that the technologies that we choose, do they provide great business value? And the two of those things together will make sure that you are providing the best value back to your business and your customers. So when we're looking at, flip through here. What are others doing in this space? So when you look at performance efficiency, the biggest thing that we see is companies that are continually refreshing, looking at their environment and making changes to that environment, not viewing it as a static resource, but they're really constantly taking the time and effort to look through whether this is something that we need to make sure that we have the latest and greatest of whatever the technology is that you're using. And so you need that continuation cycle of constantly evaluating what technologies you're using and whether those technologies are important for the services that you provide for your customers. The other thing, and sort of the biggest thing that cloud provides, is the ability to test new technology. And so, as we say, removing the burden of technology, what we're really saying is that you have the ability to test new features. You have the ability to look at additional capabilities that you may never have had in your environment, and take those capabilities and add them into your environment on a test basis before you actually commit them to production. And that's really critical to make sure that as you're looking at performance efficiency in particular, you are taking the time to really understand what are those things that would make the most impact for your business and your customers. So one of the biggest things when you look at the sort of business and technology separation is what are the things that companies want to focus on, and what are the things that technologists want to focus on. And so the most critical one, and I'm not going to pick on any one technology, but there's always the latest and greatest technology. There always has been. It's true in cloud. It was true 20 years ago in IT world. So focusing on what the latest and greatest technology is doesn't always meet the business needs. And so you have to have an honest conversation with the business and with all of the business drivers, looking at what are the things in business that you need to make sure that you're meeting with your objectives in your application, in your workload, and so that you're not taking that time away just to implement a new feature that maybe it has no direct correlation to whether your customers will be happy or not. So understanding that there is this approach where we as technologists always want to use the latest and greatest. And I love technology and I love to find the latest and greatest technology, but you have to sort of temper that with what makes the most sense for the business. So moving to things such as higher level services when you can remove operational complexity, those are obviously going to be great benefits to your company. Introducing operational complexity for the purpose of just saying that you have a piece of technology may not make the most sense. So, one of the things we always talk about is a lot of teams, they were given technology stacks over the years, and those technology stacks they had to use for everything. So, the old analogy, if you give someone, a hammer and nails, a set of nails, I should say, they view everything as a hammer because they can just swing away at it. But what if we can change that up? And so giving your technology teams the ability to change the technology that they're using without a huge burden of what the operational aspects of that's going to be. So that's one of the things that most companies that are doing this successfully, they're really removing from the technology implementation teams the burden of what they need to do for implementing these newer technology cycles. So, it's time for a poll. So one of the things that I always like to find out from customers, especially when I talk to customers, is when you have new instance types that we release, and we release them quite frequently, what sort of time frame do you take to integrate those new instance types into your environment? So we'll take a few seconds here and let everybody kind of put in the poll numbers, but I'm curious what you as customers are seeing today. So, plus it gives me a chance to take a drink of water. So it looks like most of you, 6 to 12 months, you're implementing most new instance types. That seems pretty par for the course for a lot of customers. We would like to see that time reduced for you. And obviously there's a lot of mechanisms that we can put in place to help with that. Infrastructure as code certainly helps it when, you can deploy new infrastructure with a simple change to what instance type that you're using. Gaining that efficiency of newer instance types, and sometimes even may even change the value proposition for a particular workload that you're doing is certainly critical. So evaluating those new instance types as they come in, but having all the tooling in place that makes it easy for you to consume those new instance types as they're announced is critical for your business. So we want to make sure that as we were announcing those things, that you have the ability to quickly onboard that technology. And I think that's really important for customers as well. So thanks for that poll. What are some of the sort of design principles when we look at performance efficiency? One of the biggest things is we want to make sure that we don't have the same tech stack for everyone. We want to make sure that every problem doesn't look like a nail, when all we have is a hammer. We want to make sure that we have the ability to let teams, as they're generating workloads in the cloud, that they have the ability to use advanced technologies, whatever makes sense for that workload. Don't just leave it to, well, we only have a certain standard for one particular workload type. Obviously, if you want a sort of the agility and efficiency in your business, you're going to have to be able to bring in advanced technologies as quickly as possible. So certainly letting teams make that decision on what technologies, and certainly with cloud, that is much simpler because now you can utilize those technologies much more quickly. The other big one is, going global. And I know as a former IT director for many years, the ability to implement other data centers is a sort of very time consuming and long process. So being able to take and deliver your workload pretty much anywhere in the world at this point, if you've done infrastructure as code with basically just a few clicks, that's huge. And being able to say that we now have the ability to go global and tell your business that, and tell your business leaders that you're able to take your workloads and deploy them wherever the business may need it to be is huge. And so I think performance efficiency in particular looks at how can you push this globally and make sure that you have all the infrastructure necessary to do global deployments of your infrastructure. And certainly the other half with going global is whatever compliance frameworks that you may have to meet. So certainly each country may have its own unique ones, and so being able to deploy anywhere in the world can help meet those business requirements as well. Certainly using serverless architectures is huge now, and we're seeing lots of customers fully embrace that. And it allows you to stop focusing so much on infrastructure cost and infrastructure management cost, and instead focus on what the real business value is, which is performing a task for your business. So using those serverless technologies, just taking away that complexity of having to manage and patch and all the things that you've typically had to do when you deployed standard server workloads, you certainly remove that with serverless architectures. You also want to experiment. This is where cloud is sort of been the biggest game changer for most large organizations, or really any size organization, is that you have the ability to now do things and test what happens without spinning up large amounts of capital resources. So you have the ability to really look at what does this new technology bring and what does it do for me, and spend minimal amounts of money to do that. So we want to make sure that you have the ability and you have the framework in place so that you can experiment as often as you can. And really that's critical for experimentation with the agility of your workloads. As you decide, maybe this is a new line of business that we want to get into, being able to spin that up and down very quickly and sort of test the ability for that is huge. And so I think that, being able to experiment very often and just have that constant experimental cycle is really critical. All of the restraints around what you have to do in most cases has been removed with cloud technologies. So you can now operate just about any level of technology inside of AWS. And we have things such as machine learning and transcoding and all these other sort of distributed technologies, and being able to absorb those into a particular workload is key. And so you can do that as you're pushing these experimentation cycles, and really understand what it is that your company can utilize out of that. And some of them you may, and some you may not. But obviously you want to be able to take that information and then feed it back into the business so that they understand what is possible. And we don't have to spend, a whole bunch of money to do that effort. So, one of the things that you can also do is, if you're looking at higher level services, so this is another area where we spend a lot of time of making sure that people understand that they're not forced into a specific technology anymore, right? We have the ability to get performance changes and do things because we're not forcing that technology paradigm on them anymore. You have the ability to quickly experiment, look at things like, let's say, database platforms. You may want to take a database platform from one technology type to another, and you can experiment with that, and you can see what does that really mean. And so we're not forcing those decisions ahead of time because of contractual or other reasons. We're going to experiment and do really what makes the most sense for our business. So, when you look at how are we going to do this? So, we know that we need to make these changes, but now how are we going to do that? We're going to use something like a Deming cycle for this. So what we're basically going to do is we're going to plan, do, check, and then act. So when we're going to plan what is the thing that we need to achieve. And in particular, you need to make sure that you understand what metrics you want to look at when you're trying to achieve new performance efficiencies. So you need to define those metrics up front. You need to define what frequency you're going to use those metrics, and then how you want to monitor them and analyze those. So that's the planning side of it. Then we're going to actually do it, and you're going to execute a plan. You're going to test against this. Hopefully, if you're using infrastructure as code, it's as simple as updating CloudFormation templates or whatever infrastructure tool you use, and then seeing what changes there are. So you implement those changes, and then we're going to check those. We're going to study the results of that change. Was it a positive improvement? Sometimes it may not be. Maybe those changes didn't work the way we thought. So we're going to roll those back. And if that's the case, then it's very simple to roll back. Infrastructure as code allows you to monitor different versions of that code. So certainly we can roll backwards or forwards as needed and make additional changes to test that out. So we analyze those results. We look for the behaviors that we want. And then we look for what are our values and were those changed as well. And then if we say, yes, this is exactly what we were hoping for, we reduce this particular response time, or maybe we increase the velocity of a particular piece of our application, then we can act on that and we can merge that in, move it into production, and you start utilizing that for our customers because we have planned and we know that the action will result in the pieces that we need. So, and sometimes we may say we don't. We may just take that information and say, no, we're going to use that next time. We learned something from this. We learned that it wasn't enough of a performance gain, or maybe we just didn't need that extra complexity application, and that's fine. So we may take that and say, next time we'll evolve it in a different way. So you don't always have to act on those, but you always want to continually look for what's the next thing that I can plan? What's the next thing that I can do to reduce whatever time it is and whatever metric it is that I'm tracking against? This is not a static thing. This is a thing you're going to do over and over and over again. Performance efficiency is meant to have that cycle built where you're constantly looking at ways you can iterate on that. So what can you do to constantly iterate your workload to gain performance efficiency, and what new technologies you can introduce that will introduce new parameters for the workload itself. So, all right, another poll. One of the things with monitoring, we see a lot of monitoring, and I'm going to talk for a minute while we're executing the poll here. But what's the area that you do most for monitoring? The CPU memory network. This is the old sort of triad that we used to see in most IT organizations that everyone monitors, and most monitoring tools do pretty effectively. But are you monitoring for technical KPIs? Are you looking for those key performance indicators that are outside of things like CPU memory network? Are you looking for business indicators? So, if you're an e-commerce website, are you looking for things like the number of orders per second, let's say? If you are, looking directly at how your customers are interacting. So let's say you're running some kind of a SaaS business and you're wanting to see what the customer experience is and how are they feeling about what you're doing. So let's take a second here and let's see what the results are from the poll. Looks like CPU is number one, which is what we typically would see. So in the low teens for everything else, so 55% for CPU, and it looks like 10%. So it's great, 10 or 15%, obviously looking at those other KPIs, that's critical. And you need to start defining what those KPIs are going to be for your customers. You need to have business conversations and really understand what's the most effective way that you can monitor whether your workload is effectively working for your company and your customers. If you don't do that and you don't have those business level conversations, and as technologists, I know that's kind of maybe different than what we've traditionally done, but that's critically important to make sure that you have the right metrics for your organization. So thanks for responding to that. So let's jump in and let's do some hands-on labs. So this is, I just want to iterate to everybody, this is 100 level. So this is meant to be sort of an introductory view of CloudWatch. We're going to look at CloudWatch dashboards and a few things inside of CloudWatch. It's going to give you some of the sort of basics of monitoring and give you some idea of how to generate and use data. We're going to be creating a dashboard and doing a few other things. You can follow along with this link here. And when you see this link, it'll take you to the well-architected labs. And really this lab is just showing you how to get to, let me switch over to it really quickly. So this is the lab. This is a 100 level lab. And it's really just meant to show how our CloudWatch dashboards works. So really simply, we're just going to be logging in, looking at the CloudWatch dashboard. One of the things I'll tell you is I went ahead of time and created a couple EC2 instances. You can certainly do this if you have existing EC2 instances in your environment. But if you don't, then you can create a T2 micro or some other kind of instance just to test against. But this lab, and let me just bring this back up here again, is just going to bring you straight into the CloudWatch console, and then we'll work from there. So I've already logged into my AWS account, and if you're doing this with me, obviously you can log into the account that you're going to use for your testing. First thing we need to do is log in and go to CloudWatch. You can see here from this console, I have never looked at any other service. So the first thing you can do is you can either start typing CloudWatch here under Find Services, or you can pull this down and then look here under Management and Governance. Sorry, my screen's a little big and just want to make sure. So you could click CloudWatch here, or you can type in CloudWatch, which is what I typically do. And it'll take you to the CloudWatch console. So you can see here in this console, by default, we have no dashboards, we have no alarms, we have nothing really set up yet. And in your AWS account, when you initially deploy, you're not going to have any CloudWatch stuff because you need to tell us what the things are that you want to monitor. So the first thing we're going to do is we're going to create a dashboard. I'm just going to call this. So this is just a test that we're going to do for a dashboard. And you have the ability in our dashboards to add different charts for the metrics. You have line charts, stack charts. You can take number values as well. But you can also do free text in Markdown language. So in that text field, you can also have things like playbooks and runbooks so that you know how to react when certain things occur inside of this dashboard. So if we see metrics that get out of whack, then we can have, here's the link to how to deal with metrics that are in the red in this particular way. You can also query log insights as well. But for the purpose of this demo, we're just going to stick with a simple line chart, and we're going to look at some metrics that EC2 provides. So we'll click that. When you open up the metric or open up a new dashboard, it's going to ask to add a metric. The first metric we're going to add here is out of the EC2 instance. You'll notice here under the metrics section that we have custom metrics. We also have namespaces. The namespaces are meant for what are services that we're providing that you can monitor against in CloudWatch. So you have things like EBS, EC2, and you'll notice not every service is in here. These services are added to CloudWatch as you consume them. So if you're not a user of some of our services, then you wouldn't see necessarily metrics for those until you start utilizing those services. For the purposes of this demo, we're going to stick with EC2. You can look at EC2 instances in a couple different ways. You can search by the AMI for that particular instance type. You can look at all instance types aggregated together. But what I'm going to do is a per instance metric. So we're just going to look at a specific instance in this case. So once I click there, you're going to see where it allows me to list all the instance types that I have and the particular metrics that they want. So you can do metrics on EBS volumes, reads and writes, network packets in and out, as well as total bytes, CPU utilization, and then system status checks that you can use for EC2 auto recovery. So we have these for 2 different instances that we have running in this account right now. But I know for certain the one that I want to monitor first is CPU. So we can simply type CPU in here and limit our search results to only CPU metrics. The particular machine here, I have 2 machines. I have a sender and a receiver. And so these 2 machines, I'm running iPerf on them, as well as we'll get into another tool in a second that's just going to run a load test. But basically, we're just going to generate some loads so that we can see some metrics. So the first one is the sender metric. So we're going to take the machine that is the sender, and we're going to create a widget for CPU utilization. And you can see here where the machine was spun up. It was sort of set idle. I ran some quick perf tests a little while ago, and it's been sitting idle ever since. But we're going to add that to our dashboard. So we've added this particular dashboard widget. And we can do a lot of things with this one individual widget. We can edit this widget. We can give it a name. So we know this is the sender CPU usage. And we can say that's what we want to do. We can change the period of time in which this metric is generated. So let's just say we want to go all the way down to 5 seconds and see a little more granularity on that. And we can update those widgets. One of the other things that you can do is you can also dive in, sort of zoom in to a particular time frame. So let's just say we want to see what happened during this period of time. I can zoom into that. I can keep zooming in, and I can see that at this particular time we reached 100% CPU utilization. And then at the next time interval, it dropped off to 84, and then it dropped back off to basically 0. So you can zoom in, and then whenever you're ready, you can zoom back out again. So you can see there was the initial creation of the machine, obviously high CPU, so the machine is created, and then my load test where it did another stuff set here. So we have a CPU usage for the sender machine. We're also going to add another widget. We're going to add it for the receiver machine. So again, we're going to go into EC2 and per instance metrics, and I'm going to check that, search for CPU. Here's the receiver machine. So we can create a widget for this as well, and we'll change the period of time to the same. And this is the receiver. And now we have a paired match of widgets you can see on the same timeline. So the axis, the horizontal axis here is the time. And so we can see what was happening with CPU. So obviously machine creation on both of these, high CPU. We had high CPU here, and we can dive into that a little bit more. And you can see there was a spike in CPU, but only 100% CPU on the sender, but the receiver didn't have much of a CPU spike. And that's because I wasn't running any kind of load test here. I was doing a little bit of network load and just to generate some traffic. So you can see here how we can zoom in, we can zoom out, we can see what happens during a period of time in CloudWatch. Another thing that we're going to look at is we'll take network utilization as well. So if we look here at EC2, do another per instance, and this time we're going to do the network in and out for this one. And we'll set this as well we'll set this really granular for 1 second. We'll create the widget here so this is the sender machine. And then we'll create another widget for the receiver machine. And if we go here, per instance, and this time we'll scroll down and find the receiver, and we'll also do the network in and out for that as well. Change this to 1 second just to have as much granularity as we can and create that widget. So now again, we can see stacked together the timeline for this of where CPU utilization has changed, but where network utilization also changed. You notice here that the sender network, the network out function, we had a spike of almost 10 gig of data, and we had a spike here of almost 13 gig of incoming network. So when we're sending traffic between these two EC2 instances, obviously we're able to show that there is this traffic flowing between the two. And this was something that I did earlier, but we could certainly run the same instance now. So if we go over here and we look at, this is the sender machine that I'm going to log into. And what we're going to do is we can start a stress test. And so this is just a simple Linux command to eat up some CPU time. And we'll show it for about 120 seconds here. We'll let it kind of stress the CPU a little bit. And then as that stress happens, we'll see it over here. I'm going to change my time frame here to be the last hour just so we can really zoom in on this. And while that's going, we can also have a second terminal here, and we'll also, let me zoom in to make sure you guys can see this effectively. And we will also do a iPerf, which is just a network tool that we can use to send data between two EC2 nodes, just to sort of test out that we're able to see metric changes to our graphs. So you'll notice here in a second as these things are starting to pop up, we're starting to see network traffic is obviously increasing, and we'll see CPU utilization also increasing here in a second as these graphs update. So while that's happening, I'm going to let those kind of run for a second and we can show what the impact of that is in the dashboard. But I also want to talk about alarming. So alarms in CloudWatch, you can create alarms based on any of these metrics that we talked about. And remember, metrics, while I'm showing you built-in metrics, you can generate custom metrics for any of these as well. And so for those custom metrics, you can do the same alarming mechanisms that we have for our built-in one. But for the purposes of this lab, we're going to stick with the 100 level of the standard built-in metrics. So for this, we're going to create a simple alarm, and we're going to create a CPU alarm. So we're going to select a metric here. And again, we're going to go in here to EC2, and we're going to select it per instance. We're going to look at CPU, and we're going to look at the sender machine and look at CPU utilization. And we're going to select that metric. You'll notice now under the specify metric and conditions, this is in the CPU utilization metric for this particular instance. And we're going to look at it over a 1 minute interval to try to make sure that we don't take up too much time on our workshop here. And then we're going to have a condition for this. So we have the ability to use a band as a threshold. So we can say if it's between a certain a band of evaluations, then it will do that. For the purposes of this, we're just going to hit a static one. We're going to say that if it's anything over, let's say 20% utilization, that we need to fire this alarm. There is some additional configuration, which we're not going to do, which is how many data points before you do this. And then you can also set how you deal with missing data, because one of the more critical things, you'll notice this as you're starting to do a lot of metric collection, is missing data can be just as critical as bad data as far as out of alignment data. So you need to make sure you understand, if I don't receive data for a particular data point, what should I do with that? Should I alarm for it? Or should I just go into a state of, I don't have data for this? And that can be very specific to the data type that you're collecting. But in this case, we're not going to change that. We're just going to keep it the same. And then we're going to take an action on this. So in your action, you have the ability to notify, and we're going to use Amazon SNS for this. So we are going to create a particular topic for this, and we're just going to name this. And so this will send an email to a particular email address, and we can create a new one. So let's see, we test topic. So we'll just create that. I will put in my email address, and we will create that topic now. So what that did is it created a new topic in SNS, and it's going to utilize that topic as I need to receive emails from it. I'll have to subscribe to that topic in a minute, and I will do that here in just a second, but I want to show what other actions that we have as well. So obviously with SNS, Simple Notification Service, you can trigger things such as emails, and that's what we're going to do in this test. But you can also trigger other things with SNS. So for instance, if you see an alarm state occur and you want to trigger a Lambda function, you can do that with SNS. So you can take that SNS notification and trigger any of the SNS endpoints that are available, HTTP endpoints, You can send SMS messages. There's all the features available to the Amazon SNS service you can use as a endpoint for a metric that has gone into an alarm state. You can also send notifications when this is not an alarm state and maybe it's reached back into an OK state. This is really handy when you're updating maybe external systems that are keeping track of metrics as well. So you may want to have an alarm state occur on some big board, and then you want to have that alarm go back to an OK state. You can create a notification trigger for the alarm state and the OK state, and then it will know when that's being done. And then also the insufficient data. So we just haven't collected enough data on this as well. So all those are options when you're creating notifications. We've also built in the ability to take actions such as auto-scaling actions. So if you're using EC2 auto-scaling groups, you can do that. So if you create one of these, or you're using our ECS service, which is our Elastic Container Service, you can take that and you can deploy to an auto-scaling group and say, take a particular action. That action could be based on the CPU load. Maybe we increase the number of worker nodes we have for a particular workload. Or you could also have it if there is if the threshold drops below a certain amount, maybe we say take away a certain number of nodes. So you can do all that with auto-scaling groups. For the purpose of this lab, I didn't create an auto-scaling group, but this is where you could set that up as well. You can also set these up directly in the EC2 console for when you set up your auto-scaling group. So either place you can set this. You can also take some actions on EC2 machines. So let's just say you're taking custom metrics, and that custom metric tells you something is not quite right. Maybe you're taking JVM statistics or something like that, and you say, hey, I know this is a problem. If I see this problem occur, we should reboot the machine, or we should maybe stop the instance, and if it's an auto-scaling group, that will trigger the auto-scaling group to pick up a new instance. Those are all options as well that you can create in your CloudWatch alarm. So I'm just going to do a quick notification to an email address. So we're going to do that. We can give this an alarm name. So this is the sender CPU too high alarm. You give it a description as well. And so now you will see a preview of this. So this is just showing you here's what we are creating. And in fact, you show the red line is the CPU utilization threshold for this alarm to trigger. You can see that we triggered that alarm, or would have triggered that alarm, during these different spikes during creation as well as here just a minute ago. And here are the actions that are going to occur. Whenever this occurs, we're going to send a notification to this particular topic that we created. So now we're going to create this alarm. And so the first thing you'll notice is after you create the alarm, that it has insufficient data. We have to poll enough to know what the data elements are for this particular alarm. So we're going to wait for that to occur. While that's occurring, we're also going to, I need to quickly load up a email so I can show you. Here is the notification that we received for the subscription. So when you generate SNS topics, you have to confirm your subscription to that. We don't just blindly send emails. So I'm going to confirm that really quickly. So I've now confirmed that subscription. I could also unsubscribe if I wanted to as well. And so as email alarms occur, those will now come in to that particular email address. So we're going to refresh this. This CPU is now in an OK state because we've polled it enough to know that. But we need to generate some more load so that we can have this log back in here. So let's put another stress on the CPU. Now, one of the things to note about CloudWatch alarms is we have to see this particular condition occur for more than one data point. And because our data points, the granularity is within a minute, we're going to have to wait between a minute and 2 minutes. It just depends on exactly when this gets triggered for this alarm to occur, because we need to verify that the condition has been met for that particular time frame. So we'll clear that out and we'll let that go. While that's waiting to be triggered, and we'll see this alarm come up here in a second, one of the things you can do is you can also add a widget for the alarm. I'm going to take this alarm and I'm going to add it to my dashboard. So you can see here I have the only dashboard that I have created. I'm going to create this in there. I'm going to name it the same thing that it was, and I'm going to generate that. And now if I go in here to the dashboard, not only do I see the CPU utilization now, I can also see this is the threshold for the CPU utilization alarm to occur. If I click on those, I can dive in a little deeper and see what's going on. You can see obviously in the last hour, we had a spike in traffic or a spike in CPU utilization that was due to my stress test. We're seeing another spike here occur. And right now this is not an alarm state, but after we do a second poll cycle, you will see that will suddenly jump into an alarm state. And when it does, it should trigger an alarm for us to see in our email as well. While that's occurring, you can still, as before, we can rearrange these. So if you want to take widgets and let's say, hey, we already have one of these widgets, we can remove that. So let's just say we want to delete that one. And now the widget that we have, that is the alarm widget, which also includes CPU, is there. Now you notice, just refresh this, we've now exceeded our threshold. We have an alarm state that's occurred. On the dashboard itself, we now see a red box around the alarm and a little exclamation point there. And if we go over here to our email, and excuse email, sometimes it can take a minute, so we will wait for that to refresh. And we should see an email come in as well. You can set alarms on any of these. So if we wanted to set alarms based on network traffic, we could set it on CPU and also any custom metrics that we do. We also can collect metrics as now with our CloudWatch agent. So you can collect metrics on any number of items that you want to configure on the machine. So things like memory, which is obviously critical for some of our workloads, and those things, or even the custom metrics of things like your e-commerce orders per second. That would be a great metric to have as well. So, and here's the alarm. So you can see that I have now received a message. Let me zoom in to make this a little easier to see this. So you have now received an alarm, and it's showing that the sender CPU is too high for our instance. It crossed the threshold, gives you some information about the alarm detail. Then obviously we can also click into this alarm directly within the console. And as this CPU winds down and our run is completed, so it's run for 2 minutes, it will take another minute or so for that alarm to go away. And you can already see CPU utilization has already started to dip down. So if we kind of zoom in here, you can see the last data point that occurred, it was at 68. It'll take another cycle or two for it to fully go down to 0% again. And then we'll see that this is no longer in an alarm state. So that is the general look at CPU metrics and other metrics that are generated for you. Obviously, most of our services generate metrics. Things such as like RDS, you can get information as the number of database connections, or you can get information about things such as CPU utilization, memory utilization of the database engines. So most of our services do provide those metrics out of the box, and then the custom ones you can generate as needed. So we'll wait for this to fall back off, and as you can see here, it has fallen off again, so we're back down to 0% CPU. If we look at the alarm, you'll see that it's still an alarm state, and the reason for that is we haven't had 2 consecutive data points. We've only had 1. So when the other data point occurs, we will see this go, and it has now gone green. So if we refresh this, it is green, and it is now in an OK state. So we have now made sure that our alarm is back into an OK state. So with that, let me flip back to our presentation. That is the lab that we have for CloudWatch dashboards, but we're also going to look at something else related here to in a minute. All right, so that was our So one of the things that, just to give you an example of what you can do with these CloudWatch dashboards, this is an example one. This is looking at a web app. You can look at things like load balancers in this case, so the response time for an ALB. You can look at CPU utilization, and with this dashboard, you can see that you have the ability to put all those pieces together to see the totality of your workload. Are we concerned with response time? Are we concerned with network traffic? Are we concerned with database latency? You can look at all those in one place for that workload and have a dashboard that lets you view it over a period of time. And so as you can see here, this is an example where we saw CPU utilization spiked, which also means database latency had spiked, which also means our auto scaling had spiked as well, and the number of connections also had rose. So all of these things work together, and you know that looking at these different mechanisms for metric viewing, that you can say, we see what the problem really is. Maybe it was caused by the CPU utilization going up. Everything else was just a downstream event from that. So something else that you have to think about when it comes to performance efficiency is observability. So how can we help you observe what's going on with your workload and get better insights into what's going on? For many years, most of us have built and run monolithic applications. And that was really, for a lot of companies, even today, that's the start of your cloud journey. So you're making that move from the monolithic to a more agile microservices-based architecture. And so you may be at the beginning of this journey, you may be in the middle, or even at the end of this journey. But anywhere along the way, you are having to have the information regarding the availability and the performance of that application as a whole. So when we looked at the monolithic applications, obviously there was a lot for one team to manage, and this is why the complexity of making changes. It would take months, in some cases years, to make changes to production environments because there were so many changes, so many teams involved with changes. So you would have to, unfortunately, that would slow down your ability to innovate, and it would slow down your ability to sort of reduce any of your customer concerns, or maybe introduce changes that would help differentiate your product from others. And so monolithic applications, unfortunately, just don't allow for the sort of the quick iteration that you're looking for. So as companies have transitioned, they're working into breaking up their monoliths into separate services, and those services may be owned by different teams. This allows you to be much quicker, so your agility of manipulating your workload increases the velocity of that. And this is obviously the same journey that we've been on here at Amazon. We've been moving from monolithic to microservices for many years, and it allows us the agility to make changes very quickly. But when you move to this, it obviously introduces a lot of flexibility. It also allows you to free up resources to use things other than the one stock standard application portfolio that you may have had before. So for instance, if we look at a particular component that we need to build for our workload, and that component would be better suited to be built in a different language, by decoupling all of these into separate microservices, we have that ability. We can build something, maybe the base application is built in Java, maybe we need to build something in Go or Rust, and that's what makes sense for that killer new feature that would really grab your customer's attention. By building these as independent pieces, we can certainly do that, and you don't have to change that entire code base to make that happen. You also have, when you decouple, the ability to change the way that you view the operations of this. So when you're looking at the way you're going to operate and you're going to run, you may have some sections of your code base can obviously stay on EC2 instances, in this case is VMs. You may move some to higher level services, such as RDS, where we take on the operational efficiency part of that. You may also look at things such as Lambda, where you don't actually need to have the operational complexity of running the workload on a machine. So you can certainly take and decouple your services, and you can also look at multiple different ways to run those services as well. But when you do this, the one critical piece of this is when you start decoupling and you start having this distribution of stuff, you need to have observability across all of that for the entirety of your application. So when we look at, you lose visibility. I shouldn't say you lose visibility. You struggle with visibility when you have these large decentralized systems. So you have to bring in tooling that allows you to see them across all the various components that you have. So let's just say, as an example here, your application, your workload as a whole, you may have some degraded state where you have a spike in latency, and your application goes into that degraded state. You need to be able to quickly pinpoint that. And how are you going to pinpoint that? And you need to be able to find where along the way is that latency causing you the pain. And so being able to put all these pieces together is going to be critically important as you do this decoupling exercise. So one of the ways you can do that is by looking at end-to-end tracing. So AWS X-Ray Service allows you to take your application and generate a service graph. And so with that service graph, you can take each AWS resource and you can look at how they interact with each other. So it takes these really complex services and sort of simplifies it to the point where you can look at each individual component, look at what their reaction is from each one, where's latency a problem maybe, and then see that in a totality of the service graph. And the AWS X-Ray console will show you and even generate this visualization for you. It also introduces the concept of traces. So if you want to be able to take a particular session and a particular thing that a person or another system has done, you can generate a trace ID number, and then it will track that throughout the entirety of your system. So it will collect things like the HTTP GET or POST. It'll show all of that traveling through the load balancer. It'll show it hitting your application code. It'll show any downstream services that you may be calling. So, things such as external web APIs, or maybe you're hitting even internal APIs that you've generated. And then it'll show you the time frame for each one of those inside of the X-Ray console. And it also includes the idea of segmentation within inside of that. So you can look at your compute resources running as each bit of work they do, you can view that as a segment. And the segment shows the resource name, the details about it, what work was being done. For example, when you have an HTTP request reaches your application, you can record where host it comes from, the request, the response, what work was done, and then also any issues that may have occurred. So, was a 400 error or something else where you get exception stacks for that. So X-Ray allows you to view those compute resources as different segments along the path. And really, best of all, X-Ray tracing is pretty simple to enable, especially for Lambda and API Gateway. For Lambda, it is just a simple checkbox to enable active tracing. If it's API Gateway, it's the same there. And so now you can suddenly view the application, the different calls through the application through an API Gateway or AWS Lambda. Obviously, we have workloads that don't use those two services, and so you can also enable X-ray tracing directly within your code. So when you do that, you can just, in this case, we're going to take the AWS SDK, and we're going to also require the AWS X-Ray SDK so we can see all those AWS API calls layered on top of that. So calls to things such as DynamoDB or even other higher level services, you can do that. We support this for a variety of languages, and you can look at the X-Ray homepage to see what languages we support today. And so we have a load of metrics in CloudWatch. We have all these things in X-Ray. So let's take a quick view of what X-Ray is and just kind of give you an idea of what this is. This link is to a Elastic Beanstalk sample app, but I'm also going to show you in the console how you can quickly do this with X-Ray. So if we go to X-Ray in the services into the console, you can see this is the X-Ray console here, and we're going to get started.
It's still showing your presentation.
Oh, I'm sorry.
Yeah, all right, you're back up.
Let me end this show here. Sorry. All right. Click that. Okay. Here we are. Let me cancel. Let me go back out here. So if you are in the management console and you can search for X-Ray, we open up the X-Ray console. You may see the Getting Started screen. If not, you can click up here and Getting Started. And what we're going to do is we're going to deploy a sample application. The sample application is going to show us how interacting with the different components inside of AWS happens with X-Ray. So this sample application is an Elastic Beanstalk app. It uses Node.js on the front, and it's going to build this. So I'm going to go ahead and launch this, and if you're doing it along with me, you should be able to do this as well. This is just, again, a confirmation template. We're going to launch it into our VPC. This will take about 2 minutes for this to complete. So if you just, there we go. So I'll let that run. The X-Ray sample is going to spin up an Elastic Beanstalk cluster. That Elastic Beanstalk cluster will hold the application, and we'll get to see X-Ray implemented so that it also uses a database table in DynamoDB. We'll see that. It also reaches out to SNS topics, and so you'll get to see the totality of utilizing X-Ray for that. So while that's being done, we will wait for the service map to start up. Again, we don't have a service map yet because the application is still spinning up. So one of the things I'll show while this is spinning up is whenever you're looking at the X-Ray application, and let's see what confirmation is doing here. Yep. So it's spun up an Elastic Beanstalk, and we'll see that spin up here in just a second. It also created some IAM roles and some IAM policies. As with CloudFormation, we'll just have to wait for it to spin up those resources. In the console, once we get our initial configuration, we'll be able to see the service map of the way the application is. We can look at those traces. We also have an analytics component now as well. This can take a minute. And so let me switch back while we're waiting for that to spin up. I think it might be a good chance to do our next poll, and we'll wait for that as we're waiting for CloudFormation to finish spinning up. So are you currently using a monitoring system for end-to-end requests, or is there some kind of tracing system that you're using? Do you know about that, and is it something that's widely used in your business today? This is something that I think is critically important. I know for many years we have spent a lot of time on our CPU, the sort of the trinity of CPU, network, and memory utilization. We have a lot of monitoring systems for that, but I think a lot of people are starting to see the value in having end-to-end monitoring, so you're not just looking at those sort of ancillary metric data points instead of what the customer is actually seeing. So looks like the majority of you are saying no. So it looks like about 66% are saying no, 17% yes, 16% unsure. So this is a piece that I think, as you're growing into your cloud environment, that it would be really advantageous to look at how you can do end-to-end monitoring. Obviously, X-Ray can do it. There is other tooling as well, but it's something where having that ability to see what all the components along the way are doing will be critical as you're decoupling, reducing those monoliths to individual components. It's a critical piece of that. So, all right, let's flip back and see if we're almost done with that. So what you'll see here is CloudFormation has spun up the initial X-Ray sample, and then Elastic Beanstalk is doing its work. What Elastic Beanstalk is doing is it's actually creating the various component pieces that it needs to run this, including auto-scaling groups, so the actual machine to run it. So all that's still going to be working as well. Let's see. One of the things, when this application is complete, we will see a output section here where we'll actually have the IP address of the machine that we're going to hit to see the front-end console to run this test. So we're going to have to wait for that. As anytime you're doing this stuff live, it takes longer than you expect, so we'll just have to bear with it as it's creating its auto-scaling group. X-Ray is, one of the services that we utilize with a lot of customers that just don't have visibility today. It's relatively simple to implement, and I think it's one of those pieces where customers can gain a lot of value out of their sort of the simplistic view of what the application is doing, and kind of get a better view of what pieces and parts that it's talking to. So if you haven't evaluated X-Ray, I would highly encourage you to do that. Looks like we're almost complete here. So we're still waiting for the outputs to be triggered. If you're doing this along with me, it may take a couple minutes as well for it to spin up. And at the end of this, we'll want to make sure that we spin these back down. And so we can use CloudFormation to do that. We will take this stack right here, and we can just delete it, and that will delete our stack for the X-Ray sample. But this simple Node.js app is really just a way for you to view what's going on. Okay, now we're complete. So here is when you go to the output section for this X-Ray sample, you'll see this Elastic Beanstalk environment URL. This is an IP address, and obviously it's already created all the components that it needs to run this application. This was also done in the default VPC, and that was meant so that it would have internet connectivity. So if you're deploying this in an internal VPC, you'll need to make sure that it lives in an environment that has the ability to get out through an internet gateway. So with that said, if we bring up the actual website for this, you'll see this is the X-Ray sample application. And this application is just really sort of meant to be a quick and easy way to see X-Ray in the console. So I'm going to go ahead and start this up while I explain it. So what this is doing is it's a sign-up page. So it's a really simplistic sign-up page that you can have. If we click sign up today, it will ask for your name, your email address, and then if you're interested in this preview access, and you say yes, and it says okay. That's all it does. On the back end, we're actually storing this data in DynamoDB. We're using SNS topics as well. What you'll see is when I click the start button at the top, I'm actually just generating load. So all this is doing is, hey, I'm just signing people up. So you can see here I have 6 requests that have come through so far, and this is the 7th. So I'm going to stop that. So we've had basically 8 requests come through the system. And now we can go into X-Ray, refresh the X-Ray console, and we can see the service map. So the service map is being computed for this particular application. And now we can see what this application is actually doing. So we have our end clients here. We're coming into this EC2 instance. You can see that it's hitting 3 remote services. The first one here, this SNS service, that's where we're sending things onto a topic. We could actually email individuals through this service if we so chose. We can see the average time it took to do that. We also have a DynamoDB table, and you can see that this DynamoDB table is being written to. And then this one here is interesting because this is our local instance metadata. So one of the things you'll notice is whenever the service is spun up for the first time, it also has to reach and get credentials to access things such as DynamoDB and SNS. So on the EC2 instance, it has to access that local instance metadata. That is also shown here in X-Ray as well. So we can look at not only as a map view and kind of see what the overall health is of each of these components, but we can also do a trace setup. So we can look at some different traces of, here are the URLs that were hit. We were okay on most of these. If I scroll down and look at individual ones, I can see that, here is what a GET request was, where it just got a particular instance. I can dive into this particular segment and see when it was started, what happened, what was the actual request URL, where did it come from, all that information, where's the EC2 instance that actually managed this request. All that information is available in the trace details. We can also look at a post method, and this will give you a better idea of the actual indicator of saying that this person wanted to sign up. So you can see that we have this front-end application, but this front-end application also needed to hit DynamoDB. In order to hit DynamoDB, it needed to ask for credentials. And so these credentials it got from the local instance metadata. In fact, we can even dive into that. We see here that this local instance metadata, you can see that what it requested was the security credentials for accessing this particular service. So we're able to see that if for some reason, getting the local instance metadata was taking too long, or how long did that take, we can dive into that level of detail with this. We can also see, how long did it take to actually write that particular bit of data out to Dynamo, and then what was the actual item that was put all that information is available in the trace as well. So that's just a sort of a quick overview of how to use X-Ray and how the service map can be used. And again, this is a sample application, but if you enable this for your application, it will try to find all the various component pieces that are utilized and show you traces for all of those. In order to spin down this lab, you can just go back into CloudFormation and click on the X-Ray sample, scroll back up to the top, say delete. We will delete the stack. It'll take a few minutes for it to delete as well, but it will delete it and the Elastic Beanstalk app that goes with it. That way you're not being charged for this particular application past the demo. So with that said, let's get back to our presentation here. And so when we talk about performance efficiency, and we talk about what are the questions that we need to ask, this is obviously this is part of our Well-Architected series, and I'm the performance efficiency pillar lead for that. And so there's a list of questions that we ask as part of Well-Architected that leads us to whether you're being well-architected as it relates to performance efficiency. So let's just look through some of those, and I'll kind of guide you through them. If you use the Well-Architected tool, which I'll show here at the very end, but these questions are embedded in the tool, and so this is what the tool helps you with, walking through these different questions and understanding them. So first question is, how do you select the best performing architecture? We know that it takes multiple approaches to get optimal performance. So the best way to do that is to understand all the various component pieces that are available. You have to know what services and resources are available to you to utilize so that you're utilizing the correct ones for your particular workload. You need to really have a well-defined process for selecting those architectural choices. Is there constraints that your business has put around due to regulatory concerns or other things? So obviously factoring in cost, and then maybe even utilizing external partners to help guide you on what the best way to implement or what best architectures for your particular type of workload. And then I think the most critical thing is to benchmark what you're currently doing. And so what you are expecting today so that as you make changes in the future, you have a baseline to work against when you're doing additional load testing. So obviously, first thing is, how do you select that best performing architecture? You need to select the right compute platform. You need to know what compute platforms are available in the cloud. You need to select what the most, with the best performance compute workload that you need for your particular workload. And so traditionally, you would see a lot of customers tend to just err on the side of really big. And I will say that while that's perfectly fine, there's certainly a cost component, and we also have our cost pillar that goes into some of this. But in order to make that decision effectively and be at the right cost, you need to also make sure that you're collecting any of those compute-related metrics so that you know that the selection that you made makes sense. There's nothing worse than having a machine that you're paying, a fair amount for per hour that you're using 1% of its CPU. It just doesn't make sense. So, select the right resources, making sure that you have the right metrics related to those resources so that the thing that you're selecting is the correct thing. And then obviously right sizing is part of that, where you just would say, hey, these are the things that I can do to make this smaller or bigger as the workload dictates. And then huge is to change workloads to be as elastic as possible. So you need to make sure that your resources have the ability to grow and shrink as needed based on your workload. So constantly reevaluate those, make sure that those metrics make sense for you, and then use those metrics to make decisions on what compute resources you're going to use. Same thing with storage. Make sure you understand what your storage requirements are. Evaluate what configuration options you have available, and then make sure that you make decisions based on that. So we have a lot of different storage types. We have everything from object storage and S3 to EFS to our FSX products. Those are all different products that you can do with block, file, object, you name it. We have file systems that can meet most of those demands. And you need to make sure that you may use even multiple storage services, and each component may have different storage services needed to be the most efficient it can be. Database solution. This is where we see a lot of customers spending a lot of time, especially in their initial journey to the cloud, is understanding what performance-related characteristics and other data characteristics around their database solution, and then looking at what options are available. RDS is a great option for a lot of customers where they can get rid of that operational heavy lifting that they've had to do in the past and refocus themselves on the things that are important, such as what's the best way to index and are we doing the right table space for a particular database engine type. So looking at what options are available other than just running it yourself is also big. And then again, collecting those metrics. You also need to think about data storage when it comes to database solutions. And then also looking at other database solutions that are outside of the standard ODBC style systems. Is this particular component maybe a better fit for a NoSQL database such as Dynamo, or is Elasticache with Redis a better option? Those are all things that you need to evaluate. In traditional IT, we typically stuck with one database. And the reason for that was we didn't want the operational complexity. But with cloud technologies, we can remove that operational complexity of those other services. So why not take advantage of those if it's the right thing for that workload? How do you configure your networking solution? So this is another critical piece. What are you going to be doing with how network impacts performance? What options are available for connectivity? So you need to make sure, are you connecting an on-premise database to cloud? Or are you connecting other data providers? What are your constraints related to understanding what options are available from a network perspective? Understanding what options are available, VPC options that we have, and what is necessary for that. There are also some best practices around things like minimizing the number of NACL rules and how to utilize NACL network address. Or network ACLs, but also how to compare and contrast those with AWS security groups, because that is a slightly different concept than maybe what you traditionally have done. Also selecting the right protocols, looking at when you're talking about high efficiency versus, high reliability. Is that something where you need to choose different protocols based on the workload type? And then choosing locations. Obviously, we have regions throughout the world, and we also have front-end CloudFront distribution POPs that we can use as well. So those are all things where you can choose the proper location for making it best for your customers and your workload. And then constantly evaluating the metrics related to your network. We provide lots of metrics inside of AWS for you to consume and then make the right choices for what the networking solution needs to be. And then as you collect all these metrics, you understand those, you need to have a mechanism internally to evolve your workloads over time. You need to have the ability to keep up to date with what new resources and services are available. We're releasing new services all the time, and it's important for you to understand what those services are and how they can impact your workloads. You need to define a process on how to keep up to date with those. And then you need to define a process for constantly evaluating those workloads and what the performance characteristics should be. As you evolve your business, your workload may also evolve. And so the characteristics of what you're worried about for that workload may also have evolved. So you need to make sure that you have a process to constantly reiterate what those workload characteristics should be. And then obviously just evolving the workload over time from a performance characteristic standpoint. Maybe, when you had just a few customers that the performance characteristics were much different than now that you have an established product and you have, hundreds of millions of customers. So those are things that you need to evolve over time as your product grows and changes. And then how are you going to monitor all of this? You want to make sure that, system performance, it can degrade over time. So you need to make sure that you have the ability to monitor that, have the understanding of when something gets degraded, what is your factors for that degradation, and then how are you going to remediate that? So is it a operational load problem? Is it a configuration problem? Those are all things that you need to have all those metrics in place to understand what the different options are. So you need to analyze those metrics when events occur, and then you need to establish KPIs to constantly measure the workload performance. What are those key performance indicators that you need to make sure? reviewing metrics at regular intervals, and then obviously, as we showed today, monitor and alarm on those proactively. And then trade-offs. One of the most critical things that you have to do when you're evaluating technologies is where are the trade-offs at? So when we're looking at trade-offs for, there may be an increased complexity, but we may get faster performance, or is there a pattern or change to our service that we need to make? We need to evaluate how those trade-offs can occur, and that there's also a cost trade-off. We can have the most performant system in the world, but it may cost a lot of money. Does that make sense for your workload? You need to measure and understand if that impact makes sense or not. If it's too expensive to run and your customers won't consume it, then maybe it's not the right performance that you need for that. So, and then obviously just using other performance-related strategies, trading things like, are you going to trade consistency for durability or space for time and latency? Those are things that you can trade off that may impact the way you design an application and a workload, but otherwise, it may make the most sense for that particular workload. So those are the 8 questions in the performance efficiency pillar. So now we'll ask our last poll question. So now that you've kind of heard some of the performance efficiency questions, what are questions that you think would be the most interesting for a deeper dive on? Obviously, there's the selection process, looking at what metrics to monitor and what technologies to use, reviewing those metrics, or monitoring of those metrics, or doing a deeper dive on how to select trade-offs for your workload. So we'll let that poll go for a few seconds. So it looks like a pretty overwhelming majority. 44% think that monitoring is a critical piece. 24% at wanting to know more about trade-offs, and then selection and review, not so much. So 18 and 9% for those two. So wait for one more refresh here and see what that comes back. Yeah, so the vast majority of you want deeper dive into the actual monitoring task, and I think that's a fair ask, and I think that most companies, that's where they're struggling now. And so technology such as CloudWatch and X-Ray are great examples of things to dive deeper in. And as you look at future workshops, those are things that you can focus in on to sort of add to your toolbox of things that you can implement for a particular workload at your company. So it's great. So with that, that's the end of the presentation for today, and we will go to Q&A now. So let's see here. Okay, great. So let's see what questions we have today. So question. How does X-Ray collect traces? X-Ray collects traces in a couple different ways. You can inject the SDK directly within your application. And depending on the service, if it's Lambda or API Gateway, it just injects itself directly into those API calls to give you information on that. So looking at other questions do we have here? Don't have any questions other than that one so far. Does anybody else have a question that they would like to ask? Do you recommend EKS or Fargate as it relates to which is easier to monitor and retrieve logs from? I would say that I don't have a recommendation for one over the other. As far as monitoring and retrieving logs, I think you can do on either of those. So I don't think that I have a real preference on one or the other. I think the thing you need to ask yourself is what level of infrastructure do we want to manage? When it comes to EKS versus Fargate, I mean, Kubernetes versus what we're doing with Fargate and ECS they're somewhat different. So I think that's a fundamental question you need to answer. But as far as monitoring those, we have monitoring built into both of those, and we can, certainly in EKS you can do Grafana and take those logs and dump them directly into CloudWatch as custom metrics. There's a lot of options, and then ECS we have some of those directly built into CloudWatch. How to monitor business KPIs. So this is an interesting question. There is obviously you have to have the mechanisms in place in your workload to monitor those. So the example I always use is orders per second. So that may be a metric that you're gathering through some kind of queuing system, or maybe you're gathering it through a database table. But deciding how to gather business KPIs is a critical piece, to be quite honest. And so you need to understand first you have to understand what business KPIs you want to measure. And then working backwards from that to say, now that I know these are the business KPIs I need to measure, how's the most effective way for me to gather those KPIs? And I think that's really the critical piece, is understanding which KPIs you want first, and then understanding how to work those into the application itself. You may absolutely have to generate those business metrics. You may not have those today. So that may require code changes and other things. Every webinar ends with monitoring and its resolution. How about analytics? I guess I don't quite understand the question. Let's see if I can find that one. How do we monitor application logs? Okay, we didn't go into that today, but with AWS CloudWatch logs, you can take application logs directly into directly from your application and into AWS CloudWatch logs, and then you can monitor those and actually report against those, and then have alerting based on those. You can also trigger events based on log metric filters. So again, we didn't go into that today, but those are options that are available as well. Looking for some other ones. Oh, so how do vendors complement or compete with CloudWatch? Well, I would say that CloudWatch is certainly a system that we use internally, but most of these APM vendors that we have, they directly integrate with CloudWatch. They consume logs from CloudWatch and then present it along with other information. So a lot of these vendors will take real-time user monitoring and other things and put them together in their own unique ways, and those are great. CloudWatch is built into AWS, but there are certainly others that can complement those. So there's definitely no competition there. It is certainly a cooperation between those. Let's see if there's any other ones in here. Yeah, so the analytics question was about using the data to perform analytics later. So yes, now CloudWatch metrics in general are only stored for I think it was 2 weeks period of time. But you can take that information and you can put it into external systems to utilize over time. So you can take it and put it into a Redshift cluster if you want to take analytics against it, if you want to dump it into some other kind of data warehousing system that you have. Those performance metrics and those things, you can certainly take those as well. So, can you talk about providing visibility to upper management for monitoring? Is there solutions for that? So certainly with CloudWatch, that may be a little bit too deep for some, sort of C-level if you're trying to elevate those up. But don't lose sight of the power of some of those metrics and the graphs that go with those metrics. So yes, those may be a little too deep, but you can still utilize the data out of those metrics and the actual charts themselves in other presentations that you may be giving. So showing correlation over time that a particular event occurred and that event caused these downstream services can be really powerful to show all of those things together in one sort of view. That it wasn't just that we ran out of compute or that we had to scale up compute. It's that we ended up we caused these 3 other downstream services to cause issues. So those are all things that that certainly I would utilize when you're talking to upper management. So. Last question. Any plans on enabling QuickSight on CloudWatch logs? I don't know of any. I'm sorry, I'm not the product owner for QuickSight or CloudWatch, but that's something that certainly you can reach out to your local AWS representative and see if they have any information about that. So I think that was the last question. So with that, I think that we're done.